welcome to CEC lectures. Myself Dr. Preeti Jagmani. I am from Department of Computer Science, Arvit College, University of Delhi. So presently the topic which we are covering is about transaction management, and in this topic of transaction management, what we have covered in our previous lectures is we have understood what is the transaction actually, and then we have also seen what are the properties which are related or which are required for this management of transaction. Those properties are more specifically known as asset properties, and we have also seen those properties in a quite detailed length. So now we are going to begin today's lecture along with the details of some storage structure. Now you all must be wondering that why do we need storage structure details at this particular topic or at this particular point of time when we are talking about transaction management. So to actually understand how to ensure the atomicity and durability, which we were discussing in our last lecture, also to gain a better understanding of how the various data items in the database may be stored and accessed. So here at this point of time we need to study some very little details about the storage structure, that is where actually my database is going to be stored when a transaction is going on, also when the transaction is completed. So with this basic, let us begin with today's lecture, and we will talk about the storage structure here. So storage structure, when we talk about, we will see the types of storages there in a system where we are going to use the where we are going to store our data. So first in that type is volatile storage. Volatile storage, as the name indicates, we have read in our earlier lectures of computer science also, that volatile storage or volatile memory, the biggest example of it are main memory and cache memory. So when we talk about volatile storage, that means the information residing inside that volatile storage does not survive the system crashes, or even if we can say a crash in the system, whatever information is being stored in that volatile storage will not be we cannot say that cannot be recovered, that cannot be regained, or that information or that particular piece of information is not going to survive the system crash. And the biggest example of the volatile storage is the main memory and also our cache memory. With this volatile storage, we have non-volatile storage also. So non-volatile storage, as the name indicates, the information residing onto this non-volatile storage is going to survive the system crashes. So for example, any kind of information which is written on the hard disk is something which is stored in the non-volatile storage. So your magnetic disk, your flash storages, also your online storages or tertiary storage device. For example, we talk about the magnetic tapes and optical media which are used for archival storage. So all these secondary storage devices, then all archival storage devices which are, we can say, tertiary storage devices, or your online storage is basically we can say comes under the category of non-volatile storage. Now along with this, these are two common types of storage which we if we talk about the fundamentals of computer science: volatile storage and non-volatile storage. But along with this volatile and non-volatile, here in this situation, when we are going through storage access details of database, we also have one more type of storage capacity, or we can say one more type of storage, which is nothing but the stable storage. So when we talk about stable storage, actually we can say it is theoretically impossible to obtain. Why? Because we are going to say that information residing inside the stable storage is never going to lost. So when we talk about never going to loss, that means we can say it is kind of an immortal information, which is kind of, yes, you need to take it with a grain of salt, or we can say it is kind of it is closely approximated by the techniques that is going to make that data loss extremely unlikely. But I cannot say that, or no one can say that it is unlikely to lose this particular data in each and every state, because we cannot guarantee that. That's what I was saying, that stable storage is kind of we can say is theoretically impossible to obtain. So when we talk about a transaction to be durable, that means it is going to persist even after your system is going to go into a crash after the after the successful completion of transaction. So for a transaction to be durable, its changes should be written onto the stable storage. And also similarly, we can say for a transaction to be atomic, the log records needed to be written to the stable storage before any changes are made to the database on the disk. Because in case of a system failure, when the execution is not completed yet, if we need to recover the data, if the system failure has been kind of detected, or the system has failed, and we need to restore the old state of the database, that means our log records need to be written to the stable storage, because log records are required and we do not want to lose the log records also. Now, in order to ensure the durability and atomicity, we need to see how stable is the implementation of this stable storage, that is some immortal storage which we are talking about. The more tight it is the more tightness, or the more tight is having, tight as in I am talking about secure, I am talking about the security thing. So more secure your stable storage it, and it is not going to get failed in any case. So we can say a system is going to ensure the durability and atomicity completely. Now, apart from this, we need to see the transaction atomicity and durability when this is what we are talking about, when your transaction is not going to complete the execution successfully, and the technical term for this is, we say that the transaction is being aborted. So, if we are going to ensure the atomicity, an aborted transaction must have no effect on the state of the database, and for this what we need to do, any changes that the aborted transaction is going to make to the database must be undone, or we can say the changes caused by an aborted transaction uh, needs to be undone, means the transaction has to be rolled back. So now here we talk about whose responsibility is this when the transaction aborts, and managing all the things, that is taking the transaction into a complete rollback state and doing all the changes in undone. So it is the responsibility of the recovery scheme part of the database to manage the transaction abort, and this is typically done by maintaining a log, and we have also seen the log thing in in a brief manner in our previous lecture also. So what actually here we are going to take this log into into a detailed consideration. So this says that each database modification made by a transaction is first recorded into the log, and then only after getting recorded into the log, it is going to get reflected into the actual database. So the first stage of recording this update, or recording the we can say database modification, is nothing but log. So now the question comes up that what all is going to be entered into the log. That means we need to see that what all are the log entries. So in a typical, or in any system, in a general log, the log entries will be first the identifier of the transaction performing the modification, that means the transaction identification. So, for example, in our previous lecture we have seen one transaction which was named as TI. So, we can say that is the identifier of the transaction performing the modification. Then what all data items are being changed, what all data items are being modified, the identifier of the data item being modified. So, here in our previous examples of transferring data from transferring $50 from account A to account B. So, the identifiers of the data item being modified are nothing but your account A and account B, or the identifier belonging to account A and account B. Not only this TI and account A and account B, both the old values prior to the modification as well as the new values which are after the modification of the data item. That means the old values, if we consider in our previous example, the old value of transaction A was 1000 and the for transaction B it was 2000, and the new value, assuming the transactions being completed, the new value is 950 and 2050 dollars respectively for A and B. So, if we have all this information, that is the identifier of the transaction performing the modification, that means transaction TI has performed this modification, on which items the data, on which data items the modification has been performed, the two data items A and B, account A and account B, and the old values as in like 1000 and 2000 for A and B, and the new values 950 and 2050 for A and B respectively. If all these log entries are going to be there into the log, then only we can say the database will be modified using this particular we can say log entry, or using this particular chunk of log entries corresponding to one particular transaction. Apart from that, now when we say that maintaining a log provides the possibility of redoing a modification to ensure the atomicity and durability, as well as the possibility of undoing a modification to ensure atomicity in case of a failure during the transaction execution. So, for example, a deduction from transaction A has happened and transfer to B has not been done yet. So, the transaction that is going to complete the execution successfully is known as a committed transaction. A committed transaction that has performed update transform the database into a new state, not only a new state, but a new consistent state, and which must persist even if there is a system failure. So, when we say which must persist even if there is a system failure, that means we are talking about the durability. And once the transaction has committed, we cannot do its effect by aborting it. So, for example, a transfer has been done. So, can you just in the example of this bank scenario or the account transfer, you can undo the transaction just by aborting the transaction? That cannot be done. So, in such cases we will be requiring a compensating transaction. Compensating transaction is the only way to undo the effects of a committed transaction. So, if we want to undo the impact of the transaction which is being already committed, we need to have a compensating transaction. So, for example, we say that if a transaction added $20 to an account, the compensating transaction would subtract $20 from the account. So, addition and subtraction both should go for undoing that transaction. Now, the question comes up in this scenario when I am talking about if a transaction is being added with $20, the compensating transaction would subtract $20. Is it possible to create such a compensating transaction, or is it possible to have such a system which is going to have this compensating transaction? So, writing responsibility of writing and executing a compensating transaction is always left to the user. It is not handled by the database system, because database system can abort the transaction, but it cannot write a compensating transactions. So, with this discussion, when we talk about the states of commitment, or when we talk about when your transaction is going to be aborted, we come to learn the states of the transaction. So, any transaction which is going to be executed, or which has completely completed its execution, it must be in one of the following states. Now, what are the states? So, basically there are five states of a transaction. One is an active transaction, another one is a partially committed transaction, the third one is known as the failed, fourth one is aborted, and fifth one is the committed transaction. Now, let us take them one by one. When we talk about the active transaction, we can say it is any transaction is going to stay in this state while it is executing. So, while execution is going on, we can say the transaction is in the active state, or we can say when this active state is also demarked by the initial state. So, if a transaction is in the initial state, that means it is going to begin its execution, or it has already started its execution. Both the ways we can say it's an kind of active transaction. Then what is partially committed? When we talk about the second state, which is partially committed, that is after the final statement has been executed. That means the execution is complete, but it is the updates are not being, we can say, conveyed to the database system. So, after the final statement has been executed, it is known as partially committed. Failed is the state when a user is going to discover that we cannot proceed with normal execution of the transaction. That means some system crash has been happened, or some unforeseen event has been happened, and now your transaction is a failed state. That means you from this particular point onwards you cannot go further. Then one state, or the fourth state, is known as aborted transaction. Aborted transaction says that after the transaction has been rolled back in any kind of unforeseen scenarios, the database has been restored to its state prior to the state of transaction. That means whatever is being done in this transaction till this point is going to be we can say rolled back. So, after the transaction has been rolled back, the database will be restored to its prior state. Prior state, that means the state prior to the start of the transaction. So, here the transaction is known as the aborted transaction. And finally, the last stage is the committed transaction, which is known as or which comes after successful completion. So, successful completion says that all the updates are being conveyed to the database, and they are going to be they are going to persist there, they are being written there, or we can say the state has been freeze. So, there is a thin line of difference between partially committed and committed. Partially committed says after the final statement has been executed, but your updates had not been conveyed to the system, the database system I am talking about here. And committed is after successful completion, that means the last statement has executed, and whatever updates are there, those updates are also being written onto the database system. So, here is a we can say figure of these 5 states. If you can see this on the screen, all the 5 states are given, and within these in between these 5 states there are arrows shown which are these arrows are showing that from which particular state where a transaction can go. So, now let us try to understand this figure. So, for example, we have an active transaction, it has just begun its execution. So, it can go to partially committed after successful execution of the we can say last statement, or it can go to the failed state because of some unforeseen reasons. So, even after partial commitment it can go to the failed state. So, when we say that our transaction is partially committed, that means execution is successfully execution is, we can say, done, but the updates have not been registered, have not been conveyed to the database system, and something has happened that kind of a system crash has happened. So, that in that situation it will go to the failed state. Now, here the importance of log is very much, that means either it is going to be kind of rolled back, or it is going to be finally committed. And if everything goes well, if everything goes in order, so from active to it goes to partially committed, and from partially committed it is going to enter in a committed state. And in the situation when your transaction is in the failed state and the system has discovered, or the designer or the user has discovered that from this particular point we cannot go further, that means the transaction has to be aborted. So, from active it can go to the failed and then in the aborted state, or even not from only active, if it is coming to the failed state after partially committed state, it may go into the aborted state. So, from active it can go to the partially committed or failed, from failed it will go to the aborted most likely, and from partially committed it can go to the committed, or it can go to the failed state. So, this was, we can say, a state transition diagram when we talk about the transaction in case of a database management system. So, committed it is going to enter only if it is we can say the transaction is committed only if it has entered the committed state, aborted only if it is completely aborted, or we can say it is another term which is being used here is the terminated. So, the transaction is known as the terminated transaction if it has either committed or aborted. So, either committed, that means we can say successful completion, or abort, that means the all the changes, if any is being done, are now undone. Also, that your transaction is going to start in the active state, and when it finishes its final statement it enters in the partially committed. That is what we have already discussed. And after this partial commitment it is still possible that it may have to be aborted, because at this point actual output may still be temporarily residing in the main memory, where we can say this is kind of an volatile storage, what we talked about in the starting of this lecture. And maybe a hardware failure may preclude its successful completion. That also could be a possibility. Even the database system then write out the enough information to the disk that even in the event of a failure, the updates performed by the transaction can be recreated when the system is going to restart after the failure. So, we can say a transaction entered the fail state after the system determines that the transaction can no longer proceed with its normal execution. So, such a transaction must be rolled back, and hence it entered the aborted state. Now, when a system enters into the aborted state, it can go into two options. One is it can restart the transaction, and another one is it can kill the transaction. So, in case of restart the transaction, if the transaction was aborted as a result of some hardware or software failure or error that was not created through the internal logic failure of the transaction, the restart transaction is considered to be the newer one. The second choice at the abort state is it can completely kill the transaction, and this is done because of some internal logical error that can be corrected only by rewriting the application program. So, even after aborting the situation, it is going to have the two options. One is restarting the transaction, another one is killing the transaction. So, in this lecture we have seen how different states of transaction are going to work and how are we going to ensure the atomicity and durability with the help of log files and internal storage things. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I will see you in the next lecture. Till then, goodbye. Take care.